Welcome everybody to today's FDTD Goes Applications webinar. Today we're pleased to have Jason Jordan from NWS WFO in Lubbock, Texas, leading today's presentation, which is titled Moving Toward Situational Awareness with the Geostationary Lightning Mapper, or GLM. Next slide. First, we'll talk about the recording of these. This is being recorded, and all recordings are made available on the visit web pages at the URL that's shown here. If you're interested in leading one of these in the future, contact either myself, Dan Bicus, or Scott Lindstrom, and we'll help you schedule these for one of these in the future. Next slide. In terms of our protocol, we'll have about 20 minutes for our speaker. You can either ask questions via the chat, or at the end of this, we'll have a Q&A session over the phone, and we'll be done within 30 minutes. Remember, do not press hold, and remember also to mute your phone when you're not speaking. So at this point, I will turn it over to Jason.
All right, thank you very much, and thank you all for joining, whether you're at an office, at home, with social distancing, wherever you might be. Thank you for joining us. We're going to take a look at some first thoughts and experiences here in Lubbock, how we've transitioned towards using the GLM in operations and situational awareness displays. I'm going to have to give you a little bit of a background because it's a little bit different how we have gone in and started looking at life data in general. And there's some growing pains there. And then finally, when the GLM data started flowing, we faced questions like a lot of offices did. This is great. What do we do with it now? We also had some issues where, well, it may not be working like we thought. We'll have to see what those issues could be. From there, we had a lot and are having a lot of successes, both in operations to research and research to operations. We've used it for decision support, and then, of course, situational awareness and that inside of warning operations and support. Now, your mileage will vary because this is just one viewpoint out of all the WFOs, CWSUs, RFCs, national centers, and so on that are using the GLM data. And as I said, our perspective is going to be a little bit different because we are and we're kind of ahead of the game because we have easy access to GLM knowledge. Dr. Eric Bruning at Texas Tech, who actually has written and developed the software that displays or converts the GLM data into a format that can be displayed in AWIPS, is located down the road about 5 minutes from our office at Texas Tech University. And he has made himself more than available to us, answering questions we have about the GLM, what we're seeing, and so that has really helped us figure out the best ways to use that data. We went back and looked, and then 5 years ago, I gave a presentation on how we use the West Texas LMA in our operations, and this is one of the first slides there, and this is what got us kicked off into figuring out how we would be using the GLM in the future, because from that, we were actually able to start looking at some of the things back, in this case was back in 2015, of what GLM data may look like from an LMA perspective. This is one of the earlier things that we looked at from the flash area, which is now available for the GLM. It's at a much finer resolution than the GLM at around 1 kilometer versus the 2 kilometers in AWIPS. But that started us thinking, okay, what are the best ways for us to use this for keeping aware of what storms are doing? So as we moved forward, we started the transition from AWIPS 1 to AWIPS 2 and figured out how to get the data through the various feeds into AWIPS. And this was our first version of what we may see from the GLM. We have the average flash area in this top right panel of the animation, flash extent density in the bottom left, and an early version of the source density in the bottom right with a reflexivity loop in the top left. And we're like, this is great. This is going to help us out a lot. We can start to learn what this is going to do for us. And that's where a lot of the problems began. This work was taking place as we were doing the transition from AWIPS to AWIPS 2. And so looking at the GLM data, we were competing for time. We were having to convert all of our GFE tools and everything else from AWIPS to AWIPS 2. The changes were coming fast and furious for AWIPS 2 at the same time, and so oftentimes we would make a change and get locked out because that change is no longer how AWIPS 2 would be displaying data. And we really didn't know what the final products were going to look like. We still had no plug-in available at that time to figure out what the GLM would be, or how the GLM would be displayed in AWIPS, and we're kind of taking stats in the dark. But as AWIPS 2 finally got deployed and we got into getting the data into the system, this was our first test. We got the Tower S feed into AWIPS 2 and Cave, and the first data came in, and it's like, great, it's flooding. Here's the flash extent density with the cloud-to-ground data from the GLD in there. And then the data stopped and the weather shut off for West Texas. So we got the feedback up, but since we didn't have any storms in our area, I had to go to the next best place, which was out in the Bahamas. And so this was our first look at the actual GLM data with the processing that Dr. Bruning had set up coming into AWIPS. And sure enough, it's showing what we need to do. Storms are developing. You can see kind of a life cycle here of thunderstorm taking place over the Atlantic, and you see the flash extent density ramp up, decrease, and then it picks up as the new storm to the north develops. So that's awesome. Let's overlay the Earth Networks data, since that's a global data set, and sure enough, it lines up very well. The flash and pulse data start ramping up, the CGs start ramping up, and then taper off, and then come back up with the second storm, and that's when we started having other issues. For those that aren't familiar with AWIPS, this is just a graphic kind of to give you an idea of the screen real estate that we have at any given time. We have two graphics monitors and the 19-inch text monitor, which really isn't designed for graphics handling. And with that initial display, we started running into the issues that we've all had with any of the GOES 16 series data, is that graphic data is a memory hog. Cave, if you start overlaying too many things, starts to slow down, and it can become unstable. We had to deal with questions of, okay, well, what do we overlay, how, when, where, what? And there's not as bad now, but still data delivery issues. For those that don't know how the GLM data comes into AWIPS, it gets processed at the Aviation Weather Center and some other ground stations, depending if you're a national center. That data, as it's processed into the format that AWIPS 2 can read, then goes to your regional headquarters. The regional headquarters sends it out via LDM to your local office, which then ingests the data, and you get to see it on your AWIPS display. Well, if LDM breaks or the internet goes down or any problems along any of those routes happen, then you're not going to see the data. And so until this gets switched over to the SDN where it can flow more reliably, that may just break your feed and you won't know what's going on. Some of the other issues from a user perspective were, that's great data, but I can't put this on here because I'm afraid I'm going to crash my Cave displays during an important time. Where can I overlay this data to give me what I need? And you know, we've worked through the last one, which is that looks pretty neat, but I don't need it because I've got my workflow set up. So working through those, we've kind of got it figured out that this is a radar interrogation window with an all tilt, so we can keep the GLM data on a limited loop here on the left two panes, or left two panels, and it really doesn't slow down the system performance. I've been running this for 2 years and have no crashes whatsoever related to any of this. And so it seems like we finally have that figured out. It can use the left two panes to kind of keep a broad situational awareness when we're focused on one storm. The next big issue is issues with archiving. This is just a snapshot of a screen dump that I have of any GLM case that I find interesting across all of the CONUS. And our IT officer does not like it because it's 2.5 gigabytes of just imagery data. Now, that may be a little bit different because it's not like a WES archive where the data can be displayed back in an AWIPS environment. But the advantage of doing it this way is to just have a quick reference. I don't have to reload data onto the WES. And I think that's a success with implementation. These are 29 different cases that I have of different weather events and weather event types related to the GOES 16 and the GLM. And I can pull over real quick to say, hey, we've got storms like this occurring, and so this is what I saw in the past. One of the earlier research to operations and research successes that we had in developing situational awareness is that this is a side-by-side image of a webcam that we have on top of our office and the LMA display. And we ended up catching this flash very early on in the GLM deployment, and while it was in its testing phase, and we're like, sweet, we caught this. Hey, Dr. Bruning, look at this flash we caught. This is awesome. And about a week later, he comes back and says, yeah, it's not in the GLM data. And we were kind of questioning why that would be. And what it turns out is that the orientation of the satellite is basically, if you were looking at the screen, is kind of over your top right shoulder, and this lightning bolt was over the opposite side. It came out of the opposite side of the storm from the GLM. Well, the cloud thickness was so great that it blocked all the optical energy from the GLM. So in a situational awareness case, you could be looking out the window on certain flashes and see it outside, but then looking at the GLM on AWIPS, and it doesn't see that flash. So that was kind of the first things that we had going back and forth and figuring out, okay, yeah, this is something that we'll need to be aware of, that the GLM is not going to be able to see all the flashes. It'll see quite a bit of them, 80, 90%, and even more at night, but in certain situations it may not see all of them. Operationally, from the situational awareness case, this is probably one of the first ones that we had back in July of 2018. And get a second for this loop to load because it's fairly long. General convection, there wasn't any severe weather taking place during this day, but there were questions about how the convection would evolve with time. At the top left pane, we have flash extent density with the GLD lightning data. Top right is the average flash area for any given flash with also the GLD lightning data. Bottom left is total optical energy, and the bottom right is a composite reflectivity loop for the western two-thirds of our forecast area. We had isolated convection early on, and as the evening progressed, it kind of threw an outflow boundary out, and we see the convection and the reflectivity kind of reorient into more of a convective line with a trailing stratiform region. We were able to look back in especially the flash extent density top left and the average flash area in the top right towards the end of this line that the convective cores were east of the city of Lubbock. And for those that aren't familiar, Lubbock is right about here. And with time, you can see that on the top right, we're starting to get these flashes in areas that are in the reds and the whites. And those are flash areas at or over 1,000 square kilometers. The convective leading edge was well east of the city, but we were getting flashes that were extending all the way back through the anvil. Storm chasers would call those anvil crawlers over the city of Lubbock that still posed a potential for cloud-to-ground strikes. So we could see the evolution of that with time to know, okay, yeah, the convective threat is east, but yeah, we're still going to have to worry about potential lightning strikes. And this was back on July 1st, and so there were preparations getting made for the 4th of July. The city of Lubbock that has a big fireworks show kind of gets nervous when they're setting up fireworks, and there's a lot of lightning around. And we were able to use this to say, yeah, you may not be getting any rain, you may not be seeing any ground strikes, and everything's in the cloud, but we can't give you an all clear until this entire area of flashes is east of us. Another case that we've looked at is this was the Lawrence, Kansas tornadoes back on May 28th of 2019. And this is more of just a quick overview loop for training for some of our newer meteorologists in that, hey, if you get the window set up just right and look at the right things at the right time, you'll actually be able to see trends in the lightning data to give you an idea of what may happen with the storm. In this particular case with the Lawrence, Kansas tornadoes that were pretty strong and pretty large, top left we have infrared satellite loop, top right is the flash extent density, bottom left is average flash area with total optical energy and the velocity in the bottom right. And it's hard to see in this loop because it goes so fast, but basically this is a very good case to use the flash extent density combined with the ground data to see lightning jumps. Before tornado genesis on the larger tornadoes, about 10 to 15 minutes, there was a jump in both the flash extent density and the total lightning count. And as the tornado matured and started moving off, the count started to decrease both in the ground-based and space-based networks. With the average flash area in the bottom left, you can see that as we move forward in time, you start to see periods where you're getting some of these purple and blue colors, which are very, very small flashes. And using that can tell you, hey, this updraft is fairly strong and is definitely worth something to keep an eye on. So from this case, here in Lubbock, Texas, we didn't have any weather, but I can still use the GLM because offices that receive it will get it on a CONUS scale. You can still focus on other areas to figure out what the best way is to set up a situational awareness display for look anywhere. This case was one that we used because the Lubbock 88D was down for the SLEP program, and so we were expecting storms. They took it down in the middle of May, which is our prime convective season, and unfortunately we're perfectly in the middle of 3 radars, but using the GLM combined with a composite radar loop, middle of the night, we had storms starting to fire towards the southwest of Lubbock, and based on the time tracking tool of when that was going to arrive in the city, could have posed some issues with our airport because early morning, Lubbock International Airport is a FedEx hub, and we get several flights heading out early in the morning within about 30 to 45 minutes. So we really didn't have much confidence on what was going to happen from a radar perspective because we didn't have our data. But by using the GLM, we can see, okay, top left, the flash extent density kind of ramped up there for a little bit. That may mean the storms are intensifying, but then it starts to taper off. And then when combined with the ground-based networks in the bottom 2 panes, we can see that, yeah, okay, the GLM data shows everything's gone. The ground-based networks show no electrical activity, and generally the reflectivity shows that the trend is overall downward. So we're pretty confident that if the airport were to call, yeah, it looks like the lightning threat's over, and so we could use this kind of keep a heads up of what the potential could be for convection moving into our area. Another good situational awareness display that we've kind of been playing with and been using a bit more is using MRMS data with respect to the GLM, and basically trying to combine what we know about storm electrification with what can be found with the MRMS feed, in that, here in the bottom left we have reflectivity at or above or at the minus 20 degree isotherm with flash extent density, and then the bottom right we have vertically integrated ice with the average flash area. And it's a rough proxy, poor attempt to try to figure out, again, the microphysics involved, and are we seeing storms that could have stronger updrafts that are producing more ice aloft that may produce more charge, and would that be a storm that we need to keep our eyes on? Last but not least, this was from this morning. Again, since the weather was quiet here, and I have family in Central Texas, kind of keeping an eye on the weather for them. Line of storms across Central Texas, stretching from Austin roughly up to Tyler. If you're looking at reflectivity alone in the top left, it'd be hard to tell which one of those storms would be of interest in that line. Well, once we put on the GLM data, you can see here that there's a peak in this one storm with the flash extent density in the bottom right, and then in the bottom left, the average flash area kind of has a minimum associated with it, and again, the ground-based network's also detecting a lot more electrical activity with that storm. So real quick, for situational awareness, you can throw that up there, say, where in this line of storms is something that I need to keep my eye on, and the GLM kind of focuses in your attention on that area. Now, all of these have been, kind of static images or loops, and really you're not looking for any one point in time. The key thing in keeping situational awareness is to be aware of what the trends are within all of this data. Anytime you see flash extent densities ramp up, average flash areas decrease, total optical energy ramps up, those would be areas to keep your eyes on in widespread convection. If you have isolated storms, say there's just one storm in your CWA, it's the same thing. You want to keep an eye on the trends of that to get an idea of what you may or may not be able to expect with the convection. So some final thoughts. It takes a lot of time when you get new data in, but we're getting there. The more cases we look at, the more we get to play around with overlaying different radar products or MRMS with the GLM data. We can fine-tune these situational awareness displays for different cases. We may have one for aviation if we're needing to look at that, or if there are other things that we need to do for special events or severe weather. We're still trying to figure out how to achieve a balance between workload and data overload. There's a lot of information that can be pulled out of the GLM data, but do we really need to have the radar operator looking at that while he's issuing warnings? Or do we do what has been useful at the mesoscale boot camp, where you have a mesoscale forecaster that's looking at the GLM data in the mesoscale process? As the GLM data gets widely available, not just within the Weather Service, but outside of the Weather Service on different websites, The key thing there is just stay involved, to keep the operations to research and research to operations carousel going, because somebody in the eastern part of the U.S. may see something that the western part be like, hey, yeah, that's something that we maybe could use in our area. And the big thing is just to stay accessible. You can create these things, these displays for situational awareness in a vacuum, but if you don't share them with other offices or other people to be looked at, the picture there is when I was at the hazardous weather test bed, testing some of these things out for situational awareness. It's going to be hard to figure out what is going to work best, especially now since we can't really travel and we don't know how long that's going to last. Being accessible and sharing these things through archives of just imagery or Python notebooks and just the data in general will be quite helpful. And with that, that's everything I've got, and left a little bit extra time for questions.
Okay.
The conference is now in talk mode.
Okay, any questions for Jason?
Hey, Jason, it's Brian. I have a question for you. Can you say a little bit about using the ground-based networks with the GLM?
Yes, let me get a good example here. So it's not going to be, the best caution I can give it first is that it's not a one-to-one correlation. The ground-based networks are specifically designed to detect things from the Earth versus the satellite, which is, up in geostationary orbit. And so you've got to take things into account that you may not normally, like parallax. You'll oftentimes have the GLM signatures, depending on where you are in the United States, not be co-located with what the ground networks are seeing. Another thing to kind of be cautious of is if there's a time mismatch, and this is a good example of that, where you can see in the top left panel the GLD lightning data is kind of east of where the GLM indicates that the flashes would be. That's because the GLM data is about 2 minutes behind what the ground-based networks were showing. So making sure that your time matching is set up well. And the other thing is that depending on where you are in the U.S., different networks perform differently. And so you may see flash rates be considerably different. You may have a lot of flashes in the GLM data. A good example is from early on when we were first getting data watching storms down in Big Bend. That area is pretty much in the middle of nowhere, so there's no ground-based stations to get high accuracy down there. But the GLM was able to fill in those gaps and see considerably more flashes than what the ground-based networks were, especially Earth networks. So, you need to know the caveats of what the ground-based networks have, the issues with the satellite-based detection, and figure out, okay, is everything lining up, or is this because there's an actual limitation within one of these platforms that's causing the issue or not?
All right, thanks a lot.
Okay, anybody else have a question?
Hey, Jason, this is Brian Carcione from Huntsville.
Yes, sir.
Great talk, and I appreciate your insight. I'm just curious if you have, what's your experience? You mentioned the situation where the GLM didn't pick up on the lightning flash that you caught on the webcam. How often would you say that has occurred? I mean, obviously you won't catch everything on a webcam, but have you noticed a lot of situations where the ground-based networks see it and the GLM doesn't?
That's a good question, and I know that there's research ongoing to try to figure out exactly what the numbers are. We had a case last year where we had a lightning strike take out our 88D, and we got the time because of the last data point that came in across the RD from the radar, and went back, downloaded all the data, downloaded all the ground-based networks from AWIPS, and we went back, and Texas Tech, the researchers there went back and looked at the GLM data, and that flash indeed was not in the GLM data, even though a lot of the ground-based networks all the ground-based networks saw it. So in general, I think the two cautions there would be for very strong, deep convection, especially supercells. If the viewing angle, again, depending on where the storm is oriented to the GLM and the GOES satellites, will probably have an impact on that because it'll block a lot of the optical energy. They're also now doing comparisons because out here in West Texas, we're fortunate now to be covered by both GOES 16 and 17 GLM, so you have two different viewing angles to try to figure out, okay, what exactly are the percentages that we're not seeing or seeing from both satellites. Overall, I'd say that is a rare occurrence, but not so rare that it's not something that you have to, or it is something that you have to be concerned about.
That was going to be my next question. I was curious if you felt like it was hampering adoption on anyone's part, but I appreciate the insight.
Yeah. I bet what we're going to see with time is more offices start looking at it, and as we roll out all the products to all the offices, that we'll see more and more cases. And that's another good point to make is that if you see things like that, it's important to kind of be either just marking the date or the time when it happens, so that way you can pass it on to the right people to go back and take a look at it after the event. You know, in real time, it's going to be hard to spend quality time investigating that, but going back and looking either through the West Archive or information online or handing it off, there in Huntsville or other offices that are near or co-located with research institutions that are doing lightning research, to have them look. It's definitely something that needs to be looked at, published, so that everybody's aware of what the percentages are. And then that way that'll help improve or let forecasters know, okay, yeah, this is what you need to be aware of. This is the percentage you may or may not see.
Okay, any other questions for Jason? Hearing none at this point, we'll thank Jason for a great webinar, and thank you everybody, and have a great day.